Today we're going to be studying functions, and the definition of a function is it can only have at the most one output for any one input. Is that helpful? Because it's not helpful to me. And there's a lot of things they tell you about functions that I just don't think are helpful. But this is algebra, and you're going to have to be able to identify functions, and I'm going to help you with that. For one thing that is helpful is that x cannot repeat itself. Now y can repeat itself, but x cannot repeat itself. And we're going to come back to that. The other thing that is helpful is that everything has to be reduced to 1y equals. Now 1y can equal anything. It can equal x plus 5, it can equal x squared plus 5, it can equal x cubed plus 5, it can equal anything as long as you get it down to 1y equals. And guess what? I never thought functions were very helpful until I bought a graphing calculator. And guess what? Graphing calculators only work with functions. At least mine does. And so when you're graphing with a graphing calculator, you will see y equals, and then you write in whatever formula you want to write in. But it has to be 1y equals. Y squared equals is not a function. Okay? So if you ever see y squared, it's not a function. And by the way, y squared plus x squared equals whatever, 25? Doesn't matter. That's a circle. Y squared plus x squared equals something. That's a circle. And that's not a function. Okay, so and you can't do a circle. You cannot perform a circle. You cannot graph a circle on a graphing calculator unless you cheat a little bit. I mean, there's ways you can make your graphing calculator work, but normally a graphing calculator is 1y equals, and it doesn't matter what it equals. If you get it down to 1y, it is a function. Okay, so let me show you some other things that are functions. Okay, our first graph is just a normal line. We've done a lot of those, and that is a function. And that's fine because we're used to dealing with that. This is, believe it or not, x squared. That is y equals x squared plus who knows what. It's actually minus something. But it's 1y equals x squared. Now, how did I know that? Well, by the shape of it, I know that. But the point is, remember I said x cannot repeat itself? If you draw a line straight up and down, and I only hit that line once, that's a function. Okay? That is to say, x did not repeat itself. Now, I can draw that line not necessarily there, but anywhere. Okay? Now, let's look at this. Now, look, I did the same thing. I drew a line straight up and down. See that dotted line? And I'm only hitting this curve. By the way, that's called a parabola. But I'm only hitting this curve once. And you could put that line, that dotted line, straight up and down. Not this way, but straight up and down. Anywhere, and you will not hit that line twice. That means I only have one value for x everywhere on this function. Now I do have two values for y. I can have two values for y. I can have as many values for y as I want. And as you can see right here, now that's about 2, I think, on that graph as far as x goes. But as far as y goes, it's 0. And I have y equals 0 here. And that's negative 2. And I'm just making up numbers, but one is positive and one is negative. But I'm hitting y equals 0 twice. You can't do that with x. And as you can see, everywhere on this curve, see, for every value of y here, I have the same value of y here, but I only have one value for x. Now look at this graph. I drew a line straight up and down, and I hit that parabola twice. I hit that curve twice. By the way, this is going to be y squared equals something. I think y squared equals x plus, I don't know, 2. I don't know. But this is y squared equals x plus something or minus something. But I told you cannot have a y squared in a function. This is not a function. Okay? I drew a line straight up and down, and I hit the parabola twice. And as you can see, I could draw that line in a lot of different places, in an infinite number of places actually, and I'm going to hit that line twice. I'm going to hit that curve twice. So this is not a function. Now, sometimes we're going to get a graph like this. Not in Algebra 1, and you're probably not going to even get that in Algebra 2, but in calculus, this is real common. I forget what they call that. I think they call it a sine curve or something like that. It doesn't matter what they call it as far as you're concerned. It does matter what they call it, just not as far as you're concerned. But look, you can draw a line straight up and down, see? And you're never going to hit that line twice. Now, if you drew a line sideways, you can see that y, there's going to be an infinite number of, let's say, y equals 1. We're going to have an infinite number of y equals 1. But you're only going to have, for whatever value you come up with for x, you're only going to have that value once on this curve. The sine curve, I think that's what it is. Now you may see signs like that, and the only reason they're going to show you something like that is that a function? And you go, yeah, I can draw lines straight up and down, and it doesn't matter how many lines straight up and down I draw. I'm only going to hit that curve once. Okay. Now, if it was squiggling up and down like this, okay, well, that's not a function because you're hitting that line more than once. Now, all you have to do is draw a line and hit it twice, and it's not a function. Okay, we drew a line, hit it twice. That's not a function. Now, I understand we could draw a million lines, and we're going to hit the value for x twice. A million times or a billion times or an infinite number of times. But the point is you only have to do it once to establish that it is a function or it's not a function. And if you hit that line twice, like we did here, this is not a function. Now we're going to go through some of the examples that Mr. Wallace gave us. And he does a lot more work than I do. And I'm going to make this real simple. What he does is for this first one up here, he's going to get the 3x squared over on the other side and turn that y from a negative to a positive. And you know how to do all that, right? But that's not important. What's important is what do we have here? We have 1y. And I think you know you can turn that into 1y equals. And by the way, if you're using a graphing calculator and you want to graph this, you're going to have to turn that into what Mr. Wallace does, is get everything else on the other side and make sure that y is positive. But for what we're doing here, we're just asking a simple question. Is that a function? Yes, that is a function. That is 1y equals. I only have 1y here. Okay, and then when I say 1y, I mean I don't have an exponent. I can have 3y, right? Because I can divide everything by 3 if I want. So don't let a coefficient in front of the y bother you. Don't let a negative in front of the y bother you. But I have a y with an exponent of 1. Let's put it that way. It's not y squared. It's not y cubed. It's not y to the 4th. It's y with an exponent of 1. Okay. Now, again, for the next example that he gives, he takes the y squared and he moves the x over here. And again, you know how to do that. But it doesn't matter. We have y squared here. I told you, y squared is not a function. And that's all you need to know. By the way, you can graph this if you want, but they didn't ask you to do that. I mean, you can graph this and you're going to see that it looks like a C, and it's going to be a curve that looks like a C, and then you can draw your dotted line through the graph like I did in the examples before, and you can hit that line twice if you want to do all that work, or you can just take my word for it. Y squared is not a function. Y cubed is not a function. It needs to be y with an exponent of 1. And all the rest of this doesn't matter, because the x can be x or x squared or x cubed or 25x to the 4th. It doesn't matter. And you're going to see that. If you use a graphing calculator, you can put anything in there as long as you have y to the first. And of course, we didn't have a coefficient there, or we didn't have a coefficient there either, but the coefficient in front of the y doesn't make any difference. It's the exponent. Now let's look at something else. Okay, and in the previous examples, we looked at things that were similar to that. This is 1y equals, it's a function. Okay, we don't need to know what the rest of it is. This is a function. Okay, so 1y equals 3x squared minus x. But for functions, a lot of times they get rid of the y and they'll put f parentheses x equals the same thing instead of y. And the way we read this is the function of x equals this. Now, don't be confused if you see a g here instead of the f. So it'll say g, what is the function of gx when it equals that? They can put an h there. They can put any letter there that they want. And they'll do that sometimes. I can't remember in the homework if they did that, but you might see that on the test. Don't be confused. And this, the function of x, means y. And the way we do that is we call this the range. The range is the set of all possible y values. The domain is the set of all possible x values. And if that starts looking confusing, just remember that x and y are in alphabetical order, aren't they? X comes first and y comes second in alphabetical order. So do domain and range. So if you're having trouble remembering which is the domain and which is the range, D comes before R alphabetically. So domain is going to be x and range is going to be y. So if I ask you what is the domain for this function here, well, it's all real numbers. I can put anything in x, can't I? And if they ask you what is the range for this, again, the same thing is going to be true. I can have any value here, or an infinite number of values. So let's look at something different. When you have a function that is a square root, not all answers are going to work. And the reason is because what do we know about the square root? It can't equal a negative number. So this is how we solve this. We say 2x minus 3, that is whatever is inside the root, 2x minus 3 equals 0. Now just hang with me, because when we get to the end, this will make a lot of sense. Okay, so 2x equals positive 3, and if we divide both sides by 2, x equals 3 halves. That is, x equals 3 over 2. Okay, if x equals 3 over 2, let's substitute that back in there. 2 times 3 over 2 is going to be 3. 3 minus 3 is 0. Well, can we have a square root that is a 0? Yeah. So this number is good. And any number larger than that number is good. Let's just pick a random number that's larger than that number. Let's pick 4. Okay, 2 times 4 is 8. 8 minus 3 is 5. So as long as we have a positive number under the root. Now, I'm not saying that x needs to be a positive number. I'm saying that the root, the whole root, this whole thing needs to be either 0 or positive. So we said that this is good because 3 halves is going to give us 0, and any number larger than 3 halves is going to give us a positive root. And by the way, let's just make this root negative. Let's just say, what if x was 1? Okay, 2 times 1 is 2. 2 minus 3, see, we had that's a negative root. Now we had a positive number for x. We had 1. That's positive, but the root was not positive. Don't care what x is. I only care that that root is positive. Okay, so make sure that this root ends up being positive. And how do we make it positive? Any number is good. 3 halves or greater. Okay, so x is greater than or equal to 3 halves, right? 3 halves was good, so it's equal to 3 halves. And anything greater than 3 halves was good. So x is greater than or equal to 3 halves. That is to say, if they ask you what are the functions for this function here, what are the answers for x? What are the possible answers for x? It's 3 halves or greater. And let me show you something else. Okay, I changed that from the function of x back to y. It doesn't matter. I could write this the same way. I could f parentheses x. It doesn't matter. F parentheses x is y. H parentheses x is y. G parentheses x is y. So this looks like a function, doesn't it? Well, it's not. I cannot have plus or minus a square root. Why? Because this is just the cheaty way of saying x squared equals 2x minus 3. And I put everything in there under a square root, and I said plus or minus. Now, you can't do that for a graphing calculator. And I know some of you aren't using a graphing calculator, but if you did, try that. Try putting, because I have tried. And so you might have a sideways parabola that looks like a C, and you go y squared, and if I can just get a plus or minus in there, and you go through your entire calculator looking for the plus or minus symbol, you're not going to find it. Okay, or you may be able to find it, but you're not going to be able to use it. There might be another reason why you have a plus or minus symbol in there. So, and by the way, if you did want to graph this in a graphing calculator, this is what you do. You graph it twice. You go y equals plus this root, and in the next slot right below it, if you aren't using a graphing calculator, I know you're lost, so you can just kind of skip over this or just bear with me for about 30 more seconds. And in the second slot, put y equals negative this root. And then you're going to get like a perfect graph of that non-function that I told you that you couldn't do. And that's how you do it the cheaty way. And you can do circles that way, and we're not going to get into that because that's algebra 2. But let's look at something else. Okay, and you're going to see this. And it's pretty simple. We've done this before, except that they're driving you a little bit crazy with this fx. And the way we read this is when the function of x equals 3x squared minus 4x, what is the function if x equals negative 2? Or find the function when x equals negative 2. Okay, you can see that's the function of negative 2 and that's the function of x. And basically all they're saying is when this x equals negative 2, what is the function going to be? Well, just substitute negative 2 into x and x. Okay, and that's pretty simple. Let's go over a couple of things that we already know, but there are places to mess up. This negative 2 is squared, that is the exponent applies to the x, which is negative 2. So the exponent applies to the negative 2. We are going to have a negative times a negative here, which means we're going to end up with a positive number. So, but we've done that before, but still it's a good place to mess up. And just keep track of your signs. That's a good place to get in trouble. We've gone over that before earlier in the year, that, you know, a negative is a negative. A negative times a negative is a positive. A negative times a negative times a negative is a negative. And I don't need to go through all that again, but be careful there. Okay, and then this negative 2 is going to be squared, which means a negative times a negative. And negative 2 times negative 2 is positive 4, and 3 times 4 is positive 12. And that is going to be negative 4 times negative 2 is positive 8. We're going to lose that negative sign. And 12 plus 8 is 20. So this is the way that we would write that. The function of negative 2 equals 20. In the formula that we were given, the function of negative 2 equals 20. Now let's try that again with the absolute value. And like I told you, f is not always going to be the function of x. In this case, the function of x is k, and it's not even x. We have a different variable. But, I mean, you're familiar with that. We don't need to use x all the time, and we can use any variable we like. So the function of a, when we have the function of k, equals 2 times the absolute value of a plus 4. When that is the case, find the value of a when it is negative 7 in the function k. Okay, and let's go over that again real quickly. We're looking for the function of a for the k function. And so when a equals negative 7 in the k function, we're just going to substitute this negative 7 into a, right? And that's where a was, and we've already substituted that in. And negative 7 plus 4 is negative 3. And what is the absolute value of negative 3? It is positive 3. And the absolute value marks are gone because we've turned it from a negative to a positive. And it was 2 times the absolute value of whatever that was. And so it's 2 times 3. It is 6. And so when the value of the k function for a is negative 7, the function will equal 6. And boy, you know, this is stuff that we've already done before, except that they've thrown in all that function. terminology and things like that. But if you can get beyond all the function and just basically new ways of naming things that we already understand, this should have been really simple. I hope it was. And do your homework.